In this video, we're going to play the fun party game, Is It Normal? So we have three different situations here, and we're going to try to determine whether we have reason to believe these should follow a normal model. So if we record data on the number of paper clips each person in a stats class has with them, assuming class is in person, will this be approximately normal? So would it be unimodal and roughly symmetric? Well, if you think about this, how many paper clips do you have on you right now? I have 0, but in my office, I've got a whole box. So some people might bring like 1 or 2 to class. A lot of people would probably have none. And there might be someone with a whole box. So I would say probably not. Most people have a few or 0, and a couple people might have a lot. So because of that, you'd get a right tail with the people who have a lot, and the peak would probably be pretty close to 0. So that would not be approximately normal. Next situation, we record data on the speeds of cars on I-205 between exits 14 and 17. Will this be approximately normal? Now, this is a bit of a trickier case. Traffic for a while now has been pretty clear on 205 because people are staying home with the coronavirus pandemic and all. But it kind of depends. Now, in normal situations, probably not, because most people are going roughly, a little over the speed limit. But then there are people who are going to go much, much faster than that. And so you might think, well, it's roughly symmetric because people who are going faster are matched out by people who are going slower. But realistically, for every car that's going 10 miles an hour over the speed limit, there isn't one car that's going 10 miles an hour under. Or not based on the speed limit, based on the mean. Every car that's going 10 miles faster than average, there's not a car that's going 10 miles slower than average. So I'd say probably not. There should be a right skew for the speeders of various speed love, whatever. Some people want to go 20 to 25 over on every street, so that's going to give it a bit of a right tail. So suppose we record data for this third situation on the blood pressure of healthy adults age 18 to 35. Healthy, of course, is a bit of a loaded word. So let's just say without medical conditions that would contribute to changes in blood pressure. Sometimes using a lot of words is necessary if you want to be specific, but man, it's so easy sometimes just to abbreviate. Will this be approximately normal? Well, I'm not a medical doctor, so just thinking about this, would most people be around the same, and then the same numbers of people be in each tail? And, you can think probably this could work because a lot of people will have around the same blood pressure with tails on both sides for those who are higher or lower than the mean. We don't know for sure. This is an example you can find a lot on the internet. But I think only a doctor who'd collected a lot of data would actually know if it followed normal distribution. But, just in a Stats 1 class, we can certainly reason that it would probably work. So if you see any questions on a quiz or a final exam or something about, is something approximately normal, just think about, these things. Is it unimodal? Is it symmetric? Meaning, are the tails roughly the same? And go from there.